Okay, so, oh, sorry, the video cut out, so I actually kept on teaching, so this all happened. But this isn't a whiteboard, it's just paper, so we're just going to leave it. Pretend like it's not there. Okay, so the distance between the molecules of a liquid. Table number 3, what do you guys think?
They are further apart than a solid.
Exactly. Okay, so the molecule distance are further apart than a solid. Good. Table number 2. What did you guys think about the movement of the particles of a liquid?
They move. They move.
They do move, which is better than solids, right? So they're kind of free, right? They're not too free. So they move, we'll just say fairly free. How about that? Okay, perfect. Thank you, guys. Okay, what about the distance of particles in a solid? Table number 1.
They're really close together.
Exactly, they're super close together, right? They're like almost touching. Perfect, thank you. Okay, who can tell me about the motion of the molecules in a solid?
They don't really move.
Exactly, they don't really move. They're so tightly packed that they're not able to move a whole lot, right? There's not much movement. Okay, so now that leaves us with a gas. Sometimes they are sneaky, yes, you are right. Okay, so what about the distance of molecules in a gas?
They're really far apart from each other.
Perfect. And what about their movement?
They move really quickly.
They are super fast. So they're kind of crazy. They're kind of bouncing all over the place. Not quite sure what they're gonna do with themselves. But perfect. Okay, thank you guys. Now, I'm just gonna draw up these 3 pictures of what molecules can look like in their different forms, okay? So, and these match the pictures that are in your guys' notes. So I want you guys to go ahead and just write down, I want you guys to guess, I want you guys to think what they are, write down your guess, and then I want you guys to talk to your groups for about 30 seconds, and I want you guys to come up with what you think each one of these are. Okay, so, and after 30 seconds, I'm going to have you guys hold up your hands with the number that you think represents what phase of matter each of these blocks are. So, number 1 will just be a liquid, number 2 will be solid, number 3 will be gas. Okay, so just go ahead, take 30 seconds, figure it out, write down your guesses. Okay, perfect. So, on the count of 3, I want you guys all to raise up whatever number you think it is, what this box is. Okay, so again, 1 is liquid, 2 is solid, and 3 is gas. Okay, so ready? 1, 2, 3. Perfect. Good job, you guys. That caught on pretty quick. So this is a solid. Matt, can you please tell me why you thought that this was a solid?
The molecules are all really close together.
Exactly, and that is one of our characteristics of a solid. Okay, what about this square? Okay, so think back to what your answer is. Okay, ready? Show me what finger. Ready? 1, 2, 3. Oh, this was a little tricky. I got you guys on this. Okay, so if we want to look, I'm seeing lots and lots of 1s and 3s, which is understandable. It's a little bit tricky. So the important thing to look at between a gas and a liquid is to really look at the distance between the particles. Okay? So between this particle and this second particle, is there more or less distance than the distance between these 2 particles and the others?
More.
There's more distance, exactly. So if there's more distance between the particles, what phase of matter would this actually be?
Gas.
A gas. Perfect. Okay, so this is our gas. This is number 3, which leaves this one. Okay, so 1, 2, 3. Let's see what number. Perfect, number 1. Good job, you guys. Okay, so we are now going to take a look at water, which is one of the fundamental building blocks of life. We would die without water. Kind of important. So, what is it? What do we call water in these 3 different phases? Obviously, in a liquid phase, we just call it water. We just drink that. But what about in the solid phase? What do we call that?
Ice.
Yep, perfect. And what about as a gas?
Is that
This one a little bit more difficult.
condensation? No.
What happens when you guys are cooking and you guys are boiling water?
Steam.
Steam, there we go. That's what we were looking for. Perfect. Okay, so, and we know that the phases of water will shift in between each one of these other 3 phases, right? Okay, so now I have a question for you guys. So now it's changing. It's going from a solid to a liquid, excuse me, solid to a liquid, and gas to liquid, liquid to gas. What kind of change is this? Would it be a chemical change or a physical change?
Physical.
Exactly, it's a physical change. Why is it a physical change?
Because it's still water.
Exactly, it's still water. Water is made out of H2O, and so is ice, and so is steam. What's the difference between just these 3 things?
The distance between the molecules.
Exactly, just the distance between the molecules and their motion. Because these are all the same molecule, but the distance between them and the motion are very different, which makes them into their different phases. What is one way that we are able to get these phase changes?
Cooling them down cooling water down turns it to ice.
Exactly. Okay, so if we turn down the temperature, then we get ice. What about if what if we want to try to make steam?
Heat it up.
Exactly. So in both of those cases, we are manipulating the temperature, huh? Okay, so temperature, when we change the temperature, and we are changing the energy levels of the compound. Okay? So, on your piece of paper, there are a couple of things listed that will change into other phases based upon their temperature. So I want you guys to just work with your groups, and I want you guys to fill out the charts that you guys have in front of you, and then we will come back together in a couple of minutes and see how you guys did.